Hello and welcome to PostgreSFM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and as usual, this is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Hi Michael. We are talking about snapshots, and not only snapshots, but backups of large databases and RPO, RTO. More actually RTO. RTO means how much time it would take for us to recover from some disaster from backups, right? So is it minutes, hours, days, right? For example, let's take some hypothetical database of 10 terabytes and consider what we would expect from good backup system in various managed Postgres situations and also self-managed in cloud, maybe bare metal as well. Okay. Pardon bird sounds.
It's a nice sound.
It's spring. I forgot to close the door and they decided to have a nest again here. This is what they try to do every time. Yeah.
So yeah, good topic. Why is it on your mind at the moment?
Well, yeah, it's a good question. I just observe larger databases, and I also observe different situations of managed services recently, and I see that it's really a big pain when you achieve some level of scale. Maybe not 10 terabytes, maybe 20 or 50 terabytes. And at this level, it becomes a big pain to do various operations, including backup, recovery, first of all. Backups as well, we will talk about them as well. But also provisioning of new nodes, provisioning of replicas or clones. It becomes more and more difficult. And the only solution I see is snapshots. And we have two most popular backup systems right now in Postgres ecosystem. They are PG Backrest and Volg, in my opinion. All others became less popular. This is my perception. I might be wrong. I have only anecdotal data to prove it. But it's time for both of them to seriously think about cloud snapshots in cloud environments. When I say cloud snapshots, let's clarify, I mean snapshots of EBS volumes in AWS, of PD, persistent disks, PD, SSD, or others, hyperdisk in Google Cloud, and alternatives in other clouds. I have less experience with Azure, so let's cover only all three. Mm-hmm. But again, I have much less experience with Azure. I have my main experience is with GCP and AWS. So these snapshots, I think, must be used by those who create large database systems, maintain them, and especially if you are managed Postgres provider, it's inevitable that you should rely on these snapshots of disk and restoration. And of course, I think like AWS RDS Postgres and Google Cloud Cloud SQL, they already do it. I suspect Azure also should do it, but we have many more managed Postgres providers, right?
So many now, yeah.
Right, and also we have some people who self-manage their Postgres clusters. Mm-hmm. And also we have, of course, many users who use RDS or Cloud SQL or Azure. And I think it's good to understand some details about how backups of large databases are done and the role of snapshots in those backups.
So I understand the attraction for huge databases in terms of recovery time. But are there also benefits for smaller databases as well? Or are we just fine just recovering from a normal backup like a PG Backrest style or Volg, as you say? I know, are there speed advantages or at smaller sizes as well?
That's a good question. Well, yeah, let's just let me walk us through the steps of backup and recovery.
Good idea.
With Volg or PG Backrest, let's forget about Delta backups. Let's consider like the most fundamental process. So first of all, we need to take a copy of data directory, mm-hmm. bring it to archive to backup archive, it's usually in object store like AWS S3 or Google Cloud GCS, right? And in Azure, it's blob storage, or how they call it. And this copy of data directory is not consistent by default. And it's okay. We can have inconsistent copy. We can copy data directory manually with rsync, with CP. Doesn't matter. It will take time to copy. And usually, roughly like for terabyte, it's roughly like 1 hour or half an hour. If it's faster or you're lucky, you have good infrastructure. If it's slower than 1 hour, something should be tuned. But if you have 10 terabytes, we already talk about 5 to 10 hours. If you have 50 terabytes, it's like more than 1 day, right, to copy.
Yeah.
And it's inconsistent, but it's fine because we do it between wrapping this process up with two calls, pg start backup and pg stop backup. These two important calls tell Postgres that it should keep walls that will be used in recovery. It's understood that data directory copy is not consistent, but we have enough walls to reach consistency point. So when we will recover this backup, full backup, it will be copy back to some normal disk, to another machine, right? And enough walls, and replace some walls to reach consistency point. And here's some problem. When you recover, sometimes you think, oh, how long it will take to reach consistency point. And I have a recipe in my how-to set of how-to articles, how to understand current position in terms of LSN and how long it is left to reach consistency point, because while those walls are applied, any connection attempt will be rejected, right? And Postgres needs to reach consistency point to open the gates and accept connections. And I think there was some work to improve logging of this process. And maybe it will happen in Postgres 18. I saw some discussions and some patches, I think. But before that, while we still don't have transparent logging of that process, I have some recipes, so you can use them like to be less anxious, because sometimes many minutes you wait and don't understand, and it's not fun, right? And that's it. This is full backup, but it's only part one, because it will reach consistency point, and it will represent backup for some time in the past, right? But we also need to reach the latest state of database, and for that we need second part of backups of archives is wall archive. Write-ahead log files, by default they are 16 MB. On RDS they are tuned to 64 MB. Most clusters are default 16 MB, right? So this small file is also compressed in one way or another, so it takes not 16 but say like 7 or 10 or 5 MB, depending on nature of data inside it. And then when we recover, we reached consistency point and we start replaying walls. Postgres starts replaying walls according to restore command configuration, which just tells fetch next wall and we will apply it, right? Postgres will apply it. And there's prefetching, so because of course object storage is good with parallelization. It's not a good idea to use just single process to fetch file one sequentially. We can ask to fetch 10 files in parallel to move faster, because in heavily loaded systems sometimes we see like the source, the production can generate many walls per second, and recovery can be like dozens of walls per second depending on hardware and so on. So it's worth fetching very fast. And this process can take long. Of course, like after you did full backup, many walls can be archived until the latest point. And you can restore to the latest point or to some point in time. It's called point in time recovery, right? You can configure, I need this timestamp or this LSN, and you need to wait. So, of course, it's good if you have quite frequent full backups. It means that wall replay, this additional wall replay, because there is wall replay to reach consistency point, but there is additional wall replay to reach the latest or desired point in time. It will be much less. But usually like to replay whole day of wall, it takes not a whole day, definitely. It takes like maybe like an hour or 2 hours. It depends a lot on particular case. But usually it's much faster than to generate those walls, right? But and to replay 7 days of walls, well, it might take up to 1 day, maybe less. It depends again. So people need to configure the frequency of full backups and understand that up to the whole whole period between two backups, we might need to replay this amount of walls, right? This affects recovery time as well, RTO, recovery time objective, right? Mm-hmm. And to improve that situation, both PG Backrest and WallG support Delta backups. So instead of doing like copying whole 10 terabytes or 50 terabytes to GCS or S3, they copy only Delta compared to previous backup. And then recovery looks like restore full backup and apply Delta backups. It's just some diffs of file basically, which is supposed to be faster than wall replay and also much cheaper because you don't need to keep, for example, for 7 days, you don't need to keep 7 days of full backups, but maybe you keep only one full backup plus deltas only.
Yeah.
It's already optimization of budget and also optimization of our RTO because replaying wall is slower than applying those deltas. However, we still need to start and have first full backup fetched and applied. And it's definitely slower than if we had this full backup made recently, so we just apply this and so on. Anyway, neither, like, if you use PG Backrest or WallG, they ignore existence of another alternative. Instead of copying data directly to object storage, you can use cloud native capabilities and snapshot disk. And snapshotting disk, it's also bringing data to object storage in the background, but it's on the shoulders of cloud provider, AWS or GCP or Azure. And they have this automation, they use it in many processes, and these days it's already quite reliable in most cases, right? Of course, this is, by the way, an objection I hear, like copy whole directory to object storage, it's reliable. What will happen with those snapshots? Who knows? Well, yes, okay. But a lot of mission critical systems already use them for many years, right? And it's also copied to object storage, but done in background. And it's basically, you create snapshot, it takes only minutes for large volume, like 10 terabytes, 50 terabytes. And it also is like, there is also concept of delta snapshots, like it's incremental. So there's one snapshot and then additional snapshots are done faster and take less space in object storage, so you pay less. And again, this is responsibility of cloud provider like AWS or GCP. It works, right? Then you can recover, restore, snapshot restore takes only a few minutes. This is the magic. And restore takes only a few minutes, even for like 50 terabytes. It can take like 10, 15 minutes because I'm speaking about GCP and AWS here. There is concept of lazy load. So it looks like disk already exists and data is already there, but in background it's still pulling data from object storage. And that's why it's good. Recovery is fast, but it's slow. Like, I mean, you try to select from table, but it's slow. And this concept is very well known for people who use RDS, for example, or work with EBS volume snapshots. It might be like bad in some cases, and there is trade-off. Like you may say, okay, I have a recovery time very like few minutes only. RTO is perfect in our case, but we will be slow originally, right? We will need to warm up the disks. Or you can say, okay, recovery time RTO is bad, but we are fast from very beginning. Well, we need to warm up buffer pool and page cache anyway, but it's a different story. It usually takes only minutes, not hours, definitely, right? So that's the story about snapshots. And I think that I just observe people have tendency to like snapshots and prefer them both for DR and just cloning of nodes for like purposes of creating replicas, standbys, or forking, anything. Once they reach level like 10, 20 terabytes. Before that, it's not that obvious that snapshots are beneficial. Because, okay, we can wait a few hours. If you have 5 terabytes, okay, we can wait 5 hours or 2.5 hours for backup. We can wait to recover. Couple of hours, not big deal. But once we have 10, 20, 30, 50 terabytes, it already exceeds 1 day. It exceeds 8 hours of working day, right? So it's already becomes 2-day job for someone to control this process, right? This is, I think, psychological threshold here.
But I'm just thinking there are a couple of other use cases where that time does matter. Like if you decide that you don't want to go down the logical replication route for major version upgrades, for example, and you're willing to take a certain amount of downtime, one of the steps is to clone your database, right? Do the upgrade on the clone and then switch over as on the cloud. Like a lot of cloud providers, that would be quicker or less downtime.
Why do you need a clone?
I think if you do it in place, then you're down the whole time. Whereas if you do it on a clone and then transfer any changes across that customers have made in the meantime, you might be able to minimize downtime.
How do you transfer changes?
Script. Let's say it's not super busy.
It's an interesting approach.
Yeah.
Sounds like reinventing the wheel of logical replication. So you need, if you have a complex system, how will you understand the changes?
I'm thinking mostly about quiet systems where it's unlikely that there are that many changes, or maybe zero. Like if you're doing it at a quiet time and it's like an internal system.
Well, for me, there is in place upgrade and there is zero downtime involved.
Yeah,
in logical.
sure, okay.
And logical has variations actually. But what you propose, it's kind of like it breaks my brain a little bit.
Well, all I'm thinking is I can imagine cases where being able to take a clone in a minute or two instead of it being 10 or 20 minutes is actually quite attractive for the same reason you mentioned about 8 hours. It's a different... I would stop doing another task. If something's going to take 20 minutes, I'd move on to a different task. But if it's only going to take 1 or 2 minutes, I might only check my emails. You know, like there's a very different...
it might be you need to do some research on a fork, on a clone. I call it clone. Some people call it fork. You need to verify. For example, you want to verify how long will it take to upgrade in place upgrade. Yeah. For testing, it's good to have this like identical copy of the same machine and just run all the detail, like and see the log. And how else can you check it, right? And if forking takes a day, well, and it's so
frustrating.
Yeah, it's frustrating. But if it takes only dozens of minutes, it's good. The only catch here again, there will be lazy load, right? So you need to understand, like you have a fork. It pretends it's up and running. It's up and running, but it's slow because
does that invalidate the test then?
Because then some tests will be invalidated for sure. Maybe not upgrade. For upgrade, what I would do for test of major upgrade in place with hard links, I would just in this case warm up only the system catalog part, because this is what PG Upgrade does. It dumps and restores system catalogs, like a schema,
Okay.
right?
Yeah.
And then I would ignore the remainder of data, knowing that it will be handled via hard links. So this is my warm up. It's super fast. So this is perfect example then. So but we need to understand details, internals, right?
Okay.
So we fork during some like 10, 20 minutes. Snapshot, we restore snapshot. We have up and running Postgres. We dump schema a couple of times. Well, one time is enough actually. And then we run PG Upgrade -k or hyphen links, right? And see what happens, how long it takes for us, right? And we are not worried about data actually still being in GCS or S3 or blob storage. We know it doesn't matter in this particular case. But if it's something, for example, you want to check how long it will take to run pgrepack or vacuumful or pgsqueeze on a large table without additional traffic, it's also useful data. You know that additional traffic will affect timing in a negative way, but you want to measure at least like in empty space, right?
Or even adding a new index, like how long would that
also,
take?
Yeah. In this case, the fact that we have lazy load problem with snapshot restore, well, it will affect your experiment for sure. You will have bad timing in production. You will have good timing, and you will regret you did experiment at all. You will stop trusting those experiments if you don't understand lazy load, this problem. But if you understand lazy load, you first warm up particular table, just doing, I don't know, select everything from it, right? And then create index and measure, right?
So yeah, just to get an idea, like how much slower are we talking? Is there some
How
kind
much
of rough, like
slow?
how much? Let's say you select star. How much slower would you expect it to be while it's lazy loading still versus on production?
Ooh, it's a tough question. I don't have good examples, recent examples. First time I heard about lazy load was 2015 or something. This was the first time I was working with RDS. And this is when importance of working with clones started to form in my mind. And I was super impressed like how fast we can clone a terabyte database and start working and experimenting with it. But I was upset why it's slow, so I reached out to support and they explained lazy load and their articles. By the way, AWS explains this quite well, lazy load. There's explanation in various levels, I think, both at EBS, so basic level EBS volumes, and also RDS. But I must admit, Google Cloud doesn't do a good job here in terms of documenting this. So I know it exists, I know they admit it exists, but it's not well documented. There's a good opportunity to catch up here in terms of documentation and understanding. As for your question of duration, I don't know. Like definitely it can be frustrating. So if you, select, for example, count star from a table. If it's a sequential scan, it will be same effect for warming up, right? It will not spam your output. Well, there is different way not to spam your output. Is just select from table without specifying columns, and maybe also somehow select array.
Or explain analyze.
Yeah. By the way, yes, yes. So I/O timing will be really high in that explain analyze if it's enabled. I hope it's enabled. So I think if like select count star is super slow in Postgres, we know it because it's raw storage and all the things and MVCC and so on. But here it can be order of magnitude slower. I think
makes sense.
Maybe 2 orders of magnitude. I don't have numbers here in my head.
Yeah, I was just trying to understand if it was 10% or double or an order of magnitude. And that makes way more sense.
Fetching data from object storage in background. So it can be frustrating. This is I can tell you. But you can if you aim to warm up a node just restored from snapshot, Postgres node, you can again benefit from the fact that object storage is good in terms of parallelization of operations. You can warm it up, not just single session, single connection to Postgres. You can run 10 or 20 parallel warming up queries. Right. And this is a recommendation on how to warm up because of lazy load. By the way, AWS also offers, a few years ago they implemented it. I think this is called fast restore, fast recovery, something. Fast snapshot recovery, FSR or something. I might be mistaken. But they, if my memory is right, they support up to 50 snapshots marked as available for fast restore in region, I think, for a particular account. So you can mark some snapshots and lazy load problem will disappear for those snapshots. This is a good thing to have, and I'm not aware of similar thing for Google Cloud or Azure. But this makes like once per, I don't know, week, you have a good snapshot which you can recover very fast and then replay walls. But you have super fast recovery. For experiments, it's already super cool. Right.
What about for the actual the RTO discussion? What are you seeing people with dozens of terabytes opt for in terms of that trade-off? Are they happy to accept things will be slower? It's kind of like a brownout situation for a while, but they're back online at least? Or do they prefer longer RTO, but everything works exactly as expected once it is back online?
Well, I think nobody is happy when recovery takes 10, 20, 30 hours. Nobody.
Of course.
Right? So this becomes a problem, and the characteristics of system become very bad. I mean, it becomes not acceptable for business also to understand that we will be down a whole day or two just to recover from backups. But before business realizes it, operation engineers realize, because it's really hard to experiment. So
well, and the cases where this happens are super rare, right? Like we're not talking about failover. Like with all of these setups will generally be like high availability anyway, right? So we're talking only a very specific class of recovery where you have to recover from backups. Like there's no failover situation, which I'm guessing is pretty rare. People have to think about it, but they don't face it very often.
Yeah, 10 plus years, cloud environments were super unreliable and failovers happen very often. Right now, again, at least for Google and AWS, for Google Cloud, AWS, I see nodes can be running for years without disruption. So it's much better right now in terms of failover risks. Well, again, we have habit to consider cloud environments as it's not super reliable. And for example, it also depends on particular instance classes and the sizes, I think. If you have small, very popular instance family, very small, migration might happen often. For example, we were down because we are on GCP, I mean Postgres AI, we were down because Kubernetes cluster was migrated again, like our nodes were migrated, and then we had a problem, let me admit. We had a problem with backups because after reconfiguration half a year ago, another .history file for some timeline in future, which was in the past, but for us currently was in future, was left in PG Vault directory, subdirectory. And after such migration caused by migration of VMs in Kubernetes, we couldn't start because promotion happened, timeline changed, and there was basically a rogue file from previous life corresponding to the same timeline number. It was a nasty incident. I think we were down like an hour until we figured out unfortunately, misconfiguration. Yeah, it's a bad problem. But it was good that it happened only on Saturday, so not many users noticed for our systems. And I must thank all my team for a couple of folks who jumped very quickly to Zoom and helped to diagnose and fix. So yeah, back to questions. In my opinion, again, snapshots are inevitable to use if you reach dozens of terabytes scale, right? And again, there are several levels of trust here. First level, are they consistent? Answer is we don't care because we have PG start backup, PG stop backup, right? Second question, are they reliable and what about like possible corruption and so on? Answer is test them and test backups. You must test backups anyway because otherwise it's a Schrödinger backup system, right? So we don't know if it will work. We must test. And once enough number of tests show positive results, trust will be built, right? And I have several, in the beginning of year, I announced that every managed Postgres provider must consider, highly recommended, to consider PG wait sampling and PG stat K-cache as very important pieces of observability to extend what we have with PG stat statements. Even if you are RDS and have performance insights, still consider adding PG wait sampling because this will add very flexible tooling for your customers. Now I say, for backups, of course, the big guys like RDS already use snapshots 100%. We know it indirectly from the suffer of lazy load of myself in 2015 or 16. And now all competitors of RDS or alternatives to RDS, please consider snapshots, right? Because I know you don't yet. So it's worth, because your customers grow, and once they reach 10, 20, 30, 40, 50 terabytes, they will go to RDS or self-managed and stop paying you 100%, because it's a big pain. We just described this pain. And now those who self-manage also consider snapshots, right? But most importantly, developers of WoltG and PG Backrest consider supporting snapshots, cloud disk snapshots, as official alternative to full backups and delta backups you already have. In this case, it would become native, So I think it's worth doing this. Maybe other types of snapshots. External tool for snapshotting, if it exists in infrastructure and natively supported by backup tool, I think it's a good idea. So backup tool would perform all the orchestration and skip some of full backups. It can be a mix. Ideal backup system for me would be a mix of occasional full backups, continuous wall stream, and snapshots as the main tool to provision nodes and the main strategy for DR, but not the only one. So full backups would exist separately, occasionally again, like I would have full backups. By the way, both snapshots and backups, full backups must be done, and I see it on some systems. They do it on the primary. It must be done on replicas. They must be done on replicas because it's a big stress for primary. Even snapshot is a big stress for primary, as I learned. So yeah, it's good to do it on a replica. And PG start backup, PG stop backup, they support so-called non-exclusive backups, so it can be done on replicas, on physical replicas. And even if they are lagging for some time, it doesn't matter, because even lag for some minutes, nobody will notice, because we have continuous wall stream, and replaying few minutes of wall, it's very fast.
Yeah, I saw in RDS's documentation that for multi-availability zone deployments, they take the backups from the standby.
That's absolutely all like, this is what should happen. Yeah. And snapshots also should be done from there. I saw, maybe it was specific cases, but I saw some cases when snapshot of disk of primary affected performance, because in background data is being sent to object storage, and it's definitely generating some disk read disk IO for our disks.
Yeah. So I'm curious though, why you mentioned in an ideal world you have a mix. What's the benefit of having both? Like once you move to snapshots, what's the benefit of also having like traditional PG Backrest style backups as well?
It's a good question. I remember reading Google Cloud documentation many years ago, and it said, when we create snapshot of disk, this snapshot is not guaranteed to be consistent if application is running and writing. And then suddenly this sentence was removed from Google Cloud documentation. It's a matter of trust, right? So now I trust Google Cloud snapshots and ABS Volume snapshots in AWS quite a lot. I have trust. But still, some part of me is like is paranoid, you know. So I would keep full backups, not very frequent. I would keep them just to be on safe side. But maybe over time, trust will be complete. Like if we have a lot of data proving snapshot creation and recovery is very reliable, and well, consistency, by the way, it doesn't matter. Like the problem I mentioned in documentation, it's not about snapshots are consistent or no. Honestly, I don't know even. And I don't care because I have PG start backup and stop backup, and I'm protected from inconsistent state. Postgres will take care of it. But it's a matter of trust, like lack of transparency in documentation, understanding what's happening, and so on. So only obtaining experience over time can bring some trust and understanding that the system works fine. And regular testing should be automated, recovery testing of backups, and so on. So now I think it doesn't matter if they are persistent, consistent or no. It matters if they work, right? If we can recover and then reach consistency point by our means, I mean by what Postgres has, and that's it. But still, what if I see snapshots created but I cannot use them? And also bugs happen. People change systems. I mean, cloud providers also are being developed all the time, and new types of disks and other changes are introduced all the time. And so what if snapshots will not work? If I have very reliable testing process, if I test maybe, for example, all snapshots, I restore from them automatically all the time, and I see that over the last few months, every day we created snapshot, or maybe every few hours we created snapshot, and we tested them all. Maybe at some point I will say, okay, full backups by pgBackRest or WolG are not needed anymore. So, but for now, my mind in state of paranoid. So,
very reasonable.
Yeah.
Sounds good.
Yeah. Only one interesting thing here is that to take it, if you use snapshots, there is a catch for large databases. ABS volumes and persistent disks in Google Cloud, they are limited by 64 terabytes. I think some types of ABS volumes are limited by 128 terabytes, if I'm not mistaken, so the limit is increased. But 64 terabytes, if you experience problems being at level of 10, 20, 30, 50 terabytes, 64 terabytes is not far already.
Yeah, that's true.
And then the question will be what to do. Because if you use regular backup, full backup by means of pgBackRest or WolG, you can have multiple disks, and again, doesn't matter. Thanks to pgBackRest, PG start backup, PG stop backup, you can copy data from multiple disks, right? It can be a LVM and multiple disks organized to give you more disk space, right? In your
like table spaces.
No, not table space. Table space is a different thing. It's at Postgres level. If you need to have, you can combine multiple disks using LVM2.
Oh, okay.
And have one big, basically logical volume, and for Postgres, and for regular backups, when you copy data, pgBackRest or WolG copies data to object storage. It doesn't matter that the underlying many disks contribute to build this big logical volume, because we have only files up to 1 gigabyte in Postgres. So like each huge table is shrink to 1 gigabyte files. So they are copied, compressed and copied by our backup tool. But if you start using snapshots, it's interesting.
Well, also people at that scale, people I'm thinking of the companies we've talked to at that. We had a good 100th episode, didn't we? And a lot of them are considering sharding by that point anyway. So I guess in some cases that
or
goes
deleting
away.
data, right? My favorite advice: just delete some data.
Yeah.
Don't and keep sleep well. Yeah, but well, so the problem is that it's not a problem again. It's not a problem that you will create multiple snapshots. If those snapshots are created between PG start backup, PG stop backup, you will be able to recover from them. The question will be only will LVM survive this? And this is question not about Postgres. It's a question about the cloud provider and how like snapshot orchestration. And this topic already goes beyond my current understanding of things here. I can just suggest, I can recommend, okay, use snapshots, but if you reach a limit and you need to start using LVM, it's a different story. So you need to check how LVM will survive snapshot restore
And test.
And test. Yeah. I think it's definitely solvable because like RDS solved it, right? So
Yeah, good point.
Right.
Well, that's a really good probably place to. I don't know how you're doing for time, but it makes me think about the likes of Aurora or people that are doing like innovations at the storage layer where this kind of problem just doesn't exist anymore. You know, they've already got multiple. Well, I guess we do need to still have a disaster recovery. You know, what if all of Aurora's down? We need a way of recovering, but they are promising to handle that for us in this distributed world, right? Like that's part of the promise of keeping copies at the storage layer.
Yeah, well, it's definitely new approaches where data is stored on object storage originally, not only backups, but it becomes the primary storage originally, and then there is a big orchestration to bring data closer to compute, but it's all hidden from user. It's interesting approach, but there are also doubts this approach will win in terms of the market share, right? So it's interesting. Like it definitely it's where I don't know many things. Maybe our listeners will share some interesting ideas and we can explore them, and maybe we should invite someone who can talk about this more.
Yeah, sounds good.
Yeah. But anyway, I think snapshots are great. I think they can be great for smaller databases as well. Like smaller, I mean 1 terabyte still, because instead of 1 hour, it will be a minute, right?
I think that might be. I'm curious about that area because I think there are a lot more databases in that kind of range of hundreds of gigabytes to kind of like a couple of terabytes than there are companies having to deal with dozens of terabytes. But if we can make their developer experiences much better, or
I agree. If a few terabytes, I would say it's already middle market in terms of database size. So it's very common to have 1-2 terabytes.
Yeah.
And snapshots can be beneficial because operations speed up significantly, and RTO is improved if you remember about lazy load and know how to mitigate it or accept it and live with it.
Yeah.
Good. Okay.
Nice one, Nikolai.
Thank you for listening. Again, if you have ideas in this area, I will be happy to learn more because I'm learning all the time myself. And I think Michael also is in the same shoes, right?
Yeah, I find this stuff interesting. I have to deal with it a lot less than you, which I'm grateful for. But yeah, definitely let us know, I guess, via YouTube comments or on various social media things.
Yeah, good.
Nice one. We'll catch you next week, Nikolai.
Bye-bye.
Bye.